Welcome to the FarmBits podcast.
FarmBits is proudly produced by the Nebraska Digital Agriculture Team and hosted by students at the University of Nebraska.
The FarmBits podcast comes to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews with experts, producers, and innovators from across the agricultural industry, we hope that you step away from each episode with a new practical knowledge of digital agriculture technology.
Hello, FarmBits followers, and welcome to another episode of the FarmBits podcast. I am Asya Macon.
And I'm Micah Most, and we are glad to have you with us as we continue exploring topics in precision livestock management.
Today, we are joined by Yijie Xiong, assistant professor in the Department of Animal Science here at the University of Nebraska, and two of her graduate students to discuss their research.
Let's get into our conversation.
So, Dr. Xiong, can you please tell us a little about yourself and your educational background?
Sure, thanks Asya and Micah. So I am Yijie Xiong and I'm an assistant professor in animal science department at University of Nebraska-Lincoln. So I work in both research and extension with the focus of precision livestock management. My background is I come from a very beautiful coastal city in China, which is called Dalian. And there we have almost every kind of seafood except lobster because of a different climate. Although I work in the animal science department, but my training was actually in agricultural engineering with all my 3 degrees. I got my bachelor degree from China Ag University, which is the top agriculture university in China. Then I came to the United States pursuing my graduate degrees. So I obtained both of my master and PhD from the University of Illinois at Urbana-Champaign.
Nice. And CAU has a beautiful campus. I've been there before. It's really nice. China was fun.
Have you been there before?
Yes, I've been there. I went there through my research program with NC State called P4. So it was great. Beautiful campus.
Wow, that's incredible.
I know.
Dr. Xiong, if you would share a little bit about how you got involved in animal agriculture.
Sure, and then based on my last answer, you probably would discover that it's not that straightforward because of a different background. So while I developed a passion for animals since I was a little girl and like many other little girls, and I think Asya can agree and know that kind of feeling, and that passion never fade. So I did have a little bit curved path toward working with animals. In China, the university entry exams are super, super tough and competitive. So I wasn't able to directly got involved in either animal science or veterinary medicine. Also, probably it wasn't a bad thing because soon I realized that I'm not tough enough to be a professional vet. So I went around and explored other options and discovered that I could actually work with livestock animals as well. So that's how I stick to that path. And equipping myself with engineering skills that can be applied to the livestock industry. So that's how I got involved in animal science.
Nice. That's a very interesting path. So, Dr. Xiong, how do you bring the precision element into working with livestock?
Okay. So that's a big question. And in my opinion, that's really a relatively new concept, and Asya works in the same area and you probably know what I'm talking about. And in my opinion, the precision is a really neat concept. And I remember one of the pioneer scientists in the area, and his name is Dr. Daniel Bergman from Belgium, KU Leuven. And he used to say this all the time. When he was a little boy, and he and his grandpa have a family farm. So during that time, he and his grandpa can remember and name every animal in their farm. So like when they were out and managing their animals, they just say, this is John, this is cow number 6 or something like that. But now it's the newly consolidated mode of the operations for animal farms. It is fairly impossible for the workers at the farm to keep an eye on every single animal anymore. So in my opinion, here is how the precision element comes to play. It's actually providing some tools to provide a extra pair of eyes and to supplement the human labor to help monitor individual animals in near real time.
I really like thinking about this technology as an extra set of eyes. I think that's a really good way to sum it up. Another tool to help us do our jobs to improve the welfare and quality of the livestock that we're producing. Dr. Xiong, we were wondering what your favorite species to work with was.
So this is actually a really tough question, I think. I work with many species because I was really fortunate. During my training, I got many different research projects with different species. I work with pigs, I work with chicken, I work with turkeys and dairy cattle. And I try to be equal with all of them. But right now, my favorite is beef cattle, just because I didn't have much same experience with beef cattle as with other species. And also that is one of my passion driving right now, is to focus in the beef cattle area. But I do think, if I may say, turkey posts are my least favorite because they were just so mean, especially when they're super young. And when I was caring for them, and they could just jump on my back and then pull my hair. And so that was a really tough experience. And I do not miss that part.
I'm sorry they beat you up a little bit.
Yeah.
So Josh and John, I guess we could start with John first. So what was your path to the University of Nebraska?
I got my undergrad here at the University of Nebraska. So before that, I was a college student at the University of Rwanda. I was doing agroforestry, which is also more of an integrated system to farm more and get more productivity. But once I got here, that's when I had an opportunity to kind of like now view what precision ag is and understand different components of it. So I got my undergrad with a minor in mechanized system. And after that, I pursued my master's within that mechanized system management, where we're looking at these precision ag systems that are being built and trying to learn how to sustain them and make sure that, the general public can know how to use them and effectively. So that's where my background comes in precision ag.
Cool, that's really nice.
Yeah, that was a great answer. That answered our next question, honestly. So I guess we'll ask.
So back in 2016, I was actually wanting to go to South Korea to pursue biotechnology at one of the universities. But, the fact that I had to learn Korean, for a year, kind of discouraged me to do that. And then I decided to join a scholarship to come here to UNL to do some agricultural technology so that we could go back home and do some contributions to the agricultural sector. So my background in school-wise, I was doing physics, chemistry, biology in high school, and that would mean kind of like a major, so our high schools are they have combinations. So that was my combination. So most students, they want to do medicine right after that. But, with the scholarship to come here, I came to do agriculture technology. So that's how I got here.
Awesome, and congratulations on your scholarship. You guys are very bright students, and I'm pretty sure Dr. Zhang is really lucky to have you guys.
Thank
So
you.
what are you guys' favorite species to work with? We can start with John.
I would say beef cattle because for me, I think one of the, as we say, corn is like a primary staple food or product that is now commonly like largely farmed. I think the beef cattle has that chance to kind of like be that large produce that, can be incorporated in different foods and different diets. So I would say beef cattle, but when it comes to like what I prefer as like a pet or something, a beautiful animal that I can look at, I may say chickens or rabbits. So small animals.
You don't think beef cattle are beautiful?
They are. I'm not saying they're not. It's more of the cutest level of how they look.
It's okay. I'm just messing with you. So Josh, what are your favorite species to work with?
I don't really know if I have any good answer to that because I don't really work with animals like that or have any background in animal science or with animals. So other than like, there's regular pets, dogs, cats. I don't know. Like, I don't have a good answer to that, to be honest.
That is perfectly fine.
Yeah, that's right.
And then I'll if I may interject. So Josh, even though he doesn't work directly with animals, but he's working on instrumentations and some technology and tools that can help chicken house ammonia and particulate matter monitoring. So I know you guys gonna ask question later on, and I'll defer that to him. But
Great.
he just doesn't touch the animals.
Gotcha. Well, that makes the perfect segue, I guess, into talking about your research. So, Dr. Zhang, if you would maybe describe some of your research interests. What I know is that you work with animal housing, environmental controls, and some of the data analysis that goes along with that. But I wonder if maybe you could tell us a little more in detail what you're working on.
Sure. So part of my research interest would be animal housing environmental control and data analysis or data visualization. So that closely related to my training, agricultural engineering. So a lot of people in their traditional understanding is that agricultural engineering is machinery, tractors, and those kind of thing, but there is a small sector are focused in animal housing, environment control, ventilation, those kind of stuff. And because of my training, I had the opportunity to work on, for example, temperature, relative humidity control, and gas monitoring in confined animal space. For example, I've evaluated thermal comfort conditions in commercial trailers during market peak transport and assess CO2. CO2 is carbon dioxide effect on turkey post-development. And now about applied data analysis, in my opinion, that really equals to how we can translate our research results to different audience with different backgrounds, right? Like we are scientists and we're researchers, so we know like p-values, we know all those kind of fancy statistical terms, but not everybody who wanted to make our scientific results useful may fully understand what those means. So I think it is absolutely important that we can translate that research outcome to layman term and then make sure that all people can understand it.
That's a really good description of your work, and your research interests are really amazing. I really like that. So, what projects are you working on right now?
Okay, so now being a assistant professor, now I got the privilege I can ask my students to answer that for me. So I'm going to defer that to Josh and John because they are actually doing all the hard work. And for me, it's really easy to say, but I think they definitely deserve some shine on them and explain what they're working on.
I will go first. Talk about the Intelligent Portable Monitoring Unit, or the IPMU for short. So that is a machine that we're trying to convert into an IoT product. So it has been built before for measuring emissions from poultry facilities, and those emissions are ammonia, CO2, and different the relative humidity, temperature. But one of the most important things that we're doing on this project, we're adding components to measure the PM, or particulate matter emissions. And those are extremely difficult to measure because of sensors. You gotta have a good sensor to get good data. And selecting sensors is very difficult. So the IPMU is supposed to be a very robust system, very cheap as well. And that's going to take a lot of work, the calibrating equipment, good code, for good results. So, and this system is supposed to be user friendly. So as you can imagine, if you can imagine a person going to a barn every time to extract data from whatever data logger they use, or like an SD card or something, not only does it affect their health, because they're exposed to those pollutants, it's also time consuming, and, time, money, those things. With a good system like the Intelligent Portable Monitoring Unit, those can be, reduced, or more efficiency can be achieved, in terms of time and resources. Thank you.
Amazing.
Yeah.
That is so cool.
I have a quick follow-up for that. If you could speak a little bit to maybe the harmful effects of some of the different things you're measuring, and what your goal is with generating all this data, or how would a producer use this kind of information?
Right. So I think the hard thing is to kind of make a transition. So technology has been there not that long, like computer technology, 1960, that's when most first computers were being built. But that agriculture or other practices have been there for thousands of years. So how do you transition from, something that has been being done for 2,000 years to, convincing people to, okay, so I have this new technology, it works. So yeah, that, requires some extension education and something like that. But what we really want to do, or what we really want to convey to producers, is that efficiency. So there are many examples of how computer technology or other technologies improved efficiency, in industries and everywhere. So the harmfulness of what we're trying to measure, for example, particulate matter, so there are those tiny submicron particles. So those are inhalable. So some of them are inhalable and some are respirable. So we're interested in those that are respirable, meaning that you can actually respire them. They can go down into your lungs, those alveoli, and they can affect you. So those are called PM 2.5 specifically, and to measure them, it's difficult. So we need some kind of laser technology in the sensors to measure those. So there has been published work indicating the dangers of those particles, in terms of cancers and all those. And so if we can provide a machine or a good product that can help monitor those in real time, that could be helpful. And for ammonia and CO2, I think that's more for like the health of the livestock, because if the concentration of ammonia is high in the barns, then it's probably going to affect the productivity of the chickens or other animals. So it's really useful to have a system that tracks it and analyzes it in real time to make informed decisions.
Fantastic.
For
Thank
sure.
you for sharing a little bit more about that.
That was awesome.
Jean, if you want to go ahead and share what your project is with us.
Yeah, sure. I'm working on feed bank management using imaging sensing tools. So I don't know if you guys are familiar with feed banks. They're like the bunks where they put food for feedlot cattle to eat. So normally, like traditionally, they use observation with eyes to kind of like make decisions on, okay, there is this much feed, we need this more the next day. And so with the reduction in labor, mainly in rural areas and other different challenges coming in that, like long hours of work and no breaks because cattle has to eat every day. So we are proposing to bring a solution by using this imaging sensing technology that can capture these depth images that can provide us those profile of the feed, and can help the end users, which are like those feed bank managers, to know exactly how much feed they're having without walking around the feedlot to see what's going on there, and kind of like to help them that time they walk around trying to see that, and also to add that precision part in it in order to have that feed consumption efficiency and and to make them profitable, to create that profit out of it.
So, John, what kind of image processing are you using, or what are you using to capture these images?
Yes, thank you. That's a good question. So we are using the recent camera from Microsoft, the Azure Kinect. For people who game or use these body tracking movements games, they're familiar with those cameras. So they can capture those depth images specifically that contains that data of how far a certain object is from that camera. And from there, we can build algorithms that can really provide us that volume and kind of like use it on, now we have 12 different ingredients we're trying to test to see how good response we can get from those ingredients. And then we can move on diets and see, okay, how good information we're getting from these diets, and then start proposing solutions that, feedlots can start adopting or using to help them have that feed efficiency.
Yes, that project sounds very beneficial to production. I really like that. That's awesome. So, what are you guys' biggest challenges and opportunities with your work?
I think I can go next. So with the research, you have to have valid data, so, and to get valid data, you have to follow standards, and that takes time, and you have to have, good measurements. For example, I can build a system and it can be generating data, but how good is that data? And what do I do to make the data good? And so, because the data is only as good as the system itself. So building a robust system, involves a lot of things, hardware, software, all those have to be on point. And, as you know, I don't know if you have programmed before, but developing these things, there's many failures along the way, and you have to do a lot of, testing, debugging, and all of that. So that's kind of like the main challenge, So, and also another thing is to, I don't know, like to get like previous work on the project that we're working with. For example, there's not a lot of machines that measure like PM concentration, or ammonia for livestock operations. There are some systems that measure that, but in like clean rooms application or like indoor facilities like a home, but we're working with livestock. So it's not a lot of research that has been done in that sense of like an environment where you have thousands of hens, chickens. Yeah. So yeah, that's kind of one of the challenges. And yeah, there are some challenges, but those are kind of the main.
For sure. John?
Yes. For my research in particular, it's we're still trying to get that preliminary data. So the challenge with that is, okay, we know about this solution, but how are we gonna get there? It's like those steps. Like we can do research, try those different ingredients, but it's a camera that somebody is holding, or it's on a stick. So there is like these different steps that I think may take a lot of time and also a lot of engineering effort to kind of like put all those solutions together and get a solution for farmers. Because when you go to these meetings or conferences and a farmer come to you and ask you, how is this important to me? It's so hard to tell him that a camera that was standing on a tripod can at one point shift and be part of the equipments they can use on a daily basis. So I think that's a challenge, to kind of like have that communication between research and what is actually out there and feasible. And also like gathering resources and see what really works and what doesn't work. So I think there is different challenges that we can discuss now, or it may take a long time to discuss them, but there is a lot of challenges that are within this area.
That's really interesting to hear about your perspective coming as an engineer. You kind of know your end goal and you just have to figure out how to get there from where you are now. Whereas in some of the animal science research that I'm involved with, we don't really know what our end goal is going to be. We're just trying things to see what happens. So that's a really different perspective. Not used to thinking about things that way. So thank you for sharing that.
But Micah, which is really important as well, because you're exploring. A lot of the time when we're doing research is the end goal is not always the same as you predicted. So to me, that's just two different approach, and they're equally important.
Yeah, that is a good point. And that actually leads really nicely into my next question. This is for you, Dr. Xiong. What are your main goals as a researcher in your lab? You've got these grad students working on some projects that we just heard about. I wonder if you could share maybe some more of the big picture ideas.
Absolutely. And then, like being a junior faculty, some of my mentors would advise me to go big or vision big in my career goals. And in my opinion, I can always go big, but it might be more difficult in the details. But I can share my main goals with you. That's not a problem at all. So I wanted to develop methods or evaluate innovative technologies that can be used to reduce labor requirements, which I mean is those tedious and unnecessary labor requirements to predict animal disease at an early stage, and enhance production efficiency and environmental sustainability for animal industry. So that's my big goal, but we all know that the devils are in details, right? So
Yeah, well, it sounds like you're well on your way to hitting those goals. So
Honestly,
I'm really, really glad that we have you here at the University of Nebraska as you're launching your career.
thank you. That's very nice of you guys.
So Dr. Jean, what is your favorite thing about your work?
That is actually a very simple question for me to answer. It is to have the privilege to train students and interact with them or you guys in research projects or in other development and in other occasions. And Micah also know that I'm also serving as the junior faculty advisor for the Animal Science Graduate Students Association. And I got a lot more opportunity to interact with them and see what they're going, what they have going on in their daily life. So to me, that is really the highlight of my work, and words really cannot sufficiently describe or address the feeling of achievement that I feel when I see you guys thrive in either research projects or other occasions, development, volunteering, or put really solid steps into their early career. I'm really proud of all the students that I interact with.
That's fantastic. And I'm pretty sure that they are happy as well to have you as a great mentor.
Definitely. We were wondering, Dr. Xiong, you were trained as an agricultural engineer as well as an animal scientist. How do you find the balance between those two lenses and pull from your strengths to kind of leverage those two against each other?
Thank you, Micah. I think this is an interesting question and also a tough question to answer. I honestly think it probably never actually crossed my mind when I got my hands dirty or doing field work. I guess it probably is naturally wired in my brain that I wanted to apply those practical skills that I gained from my engineering training, and particularly those related to sensors, instrumentations, and technology to solve tangible animal science questions. So I don't know if I answer your question. Like, I don't know how did I do it, but it kind of just naturally wired in me. And then knowing like getting the practical skills and use them to solve a tangible question.
Awesome. So, Dr. Xiong, we have a variety of professionals and producers who view and listen to our podcast. So, what would you tell a producer listening in on this episode who has reservations about implementing precision technology?
Yes, thank you, thank you, Asia. I'm really glad you brought up that question, because I'm doing a survey to the feed yard professionals, about their opinion, their acceptance, their knowledge, and their strategy about utilizing some of the precision technology. And from some of the preliminary completed surveys, I see different attitude towards implementing the such technologies. So my takeaway message for them is please be open-minded. And I like to use my dad as an example. I don't even want to recall how long it took me to convince him to change from flip phone to touchscreen phone, right? And I think you guys are probably too young to remember that, but I had the fortune to actually use flip phone for a short period. And even for me as a younger generation, not as young as you guys, of course, but younger than my dad, is like, it even took me like a year or so just to think, would that thing really work, right? And I just had a lot of trouble convince him to use a touchscreen phone. And even after I succeed in convincing him, he kept saying that is a piece of junk. But now, like after so many years, you just can't live without it. And I think it is a good analogy for some of the technology we're seeing right now. It might not seem to be tangible at this stage, but in the future, I believe with the technology advance and with the capital cost decrease, I think it will be a lot easier to implement as some of your operations. So be open-minded, even though I still haven't convinced my grandpa about about using any sort of phone, but I'm still trying. And that's what I'm gonna do with a lot of our feed art and feedlot and livestock folks.
Yes, that was a great answer and an even more great analogy.
Yeah. So you have students of your own now that you are preparing for their careers. So I wondered if we could have Josh and John maybe share what their hopes are for their future careers and how their experience working with precision livestock technologies might be setting them up to move in that direction.
Yeah, absolutely. I think I can safely say that we're living in a digital era, right? So soon everything is going to be online, and most of the things are going to be monitored from home remotely. So this is a very big opportunity towards that, because right now we're learning about these technologies, and then later on we're going to build on what we're learning here, and then we will be developing even bigger systems, given the trend of today's technology. So I really believe that this is an amazing opportunity to work towards that goal for the future.
I may say that for me, like coming from Rwanda, which is a small country with limited resources, one of the important things is, okay, with limited resources, what can we do with it in order to be efficient with production? So I think technology is part of it. It takes a big part of it. Like using technology really makes things more efficient and more user friendly. And as Joshua just mentioned, we're in a technology revolution where everything is no longer being hands. Now we are using computers and different things. So for me, my goal is just to take part of it, to take part of that revolution, and kind of like as young generation to be the drivers of those changes. And if I don't know where my career may end up with, but I'm pretty sure whatever it goes is try to keep that spirit up, that we are the drivers of this technology change and we have to maintain that.
Well, wherever you guys go, I'm pretty sure it will be your careers or your future will be very bright. So Dr. Zhang, what are you most excited about for the future of precision animal agriculture?
Sure. And I think both Josh and John provide a really good beginning of how I wanted to answer your question, Asia. Because we are absolutely in a revolutionary and digital era, right? And then that is just a fact. And I really have a bright vision about the future of precision animal agriculture or digital agriculture for crops, as you may couple them together. Although what we can also say, and I think it's true as well, so we are faced with many changing challenges in this dynamic world right now. COVID, and then a growing need for food, etc. But I still think that we have a bright future for this area, especially after some of those prototype technologies that John and Josh and then myself and others like-minded scientists and researchers are working on become fruitful and become practical to be applied in those specific areas. And I think also important is we have to respect the important role of agricultural business brain, because bottom line, the agriculture businesses produce the food that feed the whole world, right? So I have really positive view about that, even though we are having some challenge, but I'm pretty sure with the young generation like John and Josh and you guys, Asian Micah, become the driver of either the industry, the research, or the consumer demand community, we can conquer those challenges and make this even a brighter place for all of us.
Thank you for that answer.
Yeah. I guess, is there any other thoughts you want to share with us that you haven't, or anything you feel like you need to get off your chest that we haven't asked you about?
Well, I don't think so, but if whoever listening have young generation that wanted to study in this area, please reach out to Micah and Asya, and they can link you up with a few really bright-minded researchers at University of Nebraska-Lincoln. There are some really, really cool research going on, and I'm sure we all need students and young professionals that we wanted to train and want them to thrive.
Sure. Yeah. We touched on this a little bit, but do you have any specific advice, Dr. Xiong, for any like young professionals in animal agriculture or interested in using engineering to improve animal welfare and animal productivity?
Yes, absolutely. And like now that it's not that long since my graduation, but still like I feel the transition and the difference really easily. So my advice to you guys is learn as much as you can. Absorb the knowledge as you were a sponge. Because really, I think there's no better opportunity than right now for you to learn more knowledge, more skill, that you don't have to worry too much about the real life challenges and difficulties, right? So learn as much as you can, and don't be afraid of new technology and the new knowledge that you haven't got a chance to know. Because just with time and some effort and some determination, you can be an expert as well.
Wow.
Thank you for your advice.
Yeah, that was great.
I'll definitely walk away remembering that today. Thank you very much to Dr. Jean, Josh, and John for taking the time to join this episode of the FarmBits podcast. It was really exciting to learn about the different image sensing technologies and different sensors used to monitor environmental controls.
One of my favorite parts of this episode was hearing the different perspectives brought to the table, using engineering approaches to solve problems in animal agriculture and the future of some of these precision technologies and their potential for applications. I hope you enjoyed this episode, and we look forward to sharing another digital ag story with you next week.